In our previous modules, we've looked at various types of sequences. Remember, a sequence is a Python nomenclature for how we store collected groups of data. So we've looked at lists, we've looked at tuples, we've looked at dictionaries, and today we want to look at sets. Now, sets is a little bit different than the others, mainly because a set comes from the mathematical term of a set. So if you understand math, you understand how sets work in math, you're going to find that sets are very easy to work with. In fact, for the most part, when we use sets in Python, it's going to be because we're doing some sort of math. There's usually not a lot of reasons to use it outside of that. But because Python can be used to demonstrate mathematical concepts, to do different types of mathematical analysis, etc., that does have built into it this data structure called a set. So if you're not familiar with a set in math terms, let me give you a quick rundown of what that is. Basically, it means that is a group of objects, and you can only have one of a given value inside of that object. So for example, let's say that you have a shopping cart. You go and you order things online, you're on Amazon, you order widgets, you order gadgets, you order thingamabobs. Well, you don't want to see widget, okay? You would just want to see widget and maybe quantity 3. And so you can kind of think of that shopping cart as a set. There's only one of a given item. Now, you can have multiple items, of course, but there's only one of a given item, and then you just adjust the quantity for that object. Okay, so that's kind of a very simplified example of what you might see. So to create a set is real easy. I'm going to say in this case, my set equals set. And this creates an empty set. So with all of our possible sequences we've had before, we can always create an empty version. This is how we do it. And if I say print my set, then it will print it out. Right now, there's nothing in it. So if I go and I print this, you're going to notice that it just says set, and it's just the empty set itself. So let's put some data into it. Well, I might start off with something like ABC, and here's a string. You might go, okay, well, what's the point of having a string? I don't get that. Well, when you use that set function, and this function is something that comes with Python so it can create sets. When you use this function on ABC and we run our code, you're going to notice that now instead of showing an empty set, it shows curly braces, kind of like it did with the dictionary object, and it shows each of those individual letters. Now, there's a couple of interesting things about that. Notice that unlike a dictionary, there's no key in value. It's just the values. Also notice that while we put ABC as one string, it broke it up into its individual letters. So now we have a set that has those individual letters. You'll also notice that those letters are not in the same order that we put our set in. So one of the things about a set is that the order of the values does not matter. So we cannot assume that the order that we put things in is going to be the order that it's going to be stored or returned to us. Okay, let's make one more little change. You can do AAA, BBB, CCC. Remember, because it splits up that string and we can't have duplicate values in our set, when I go and run this, you'll notice that it still prints out CAB. Okay, so internally, anytime it said, oh, I've got an A, do I have an A? Nope, let me add it. It sees the second A and goes, oh, do I have an A? Yes, I do. It ignores it. Oh, I've got a B. Let me see a B. Oh, don't have one of those. I'm going to add it. Oh, I see another B. I've got one of those. Ignore it. Another B. Ignore it. C. Oh, this is new. And so it stores it internally this way. Now, it is a little bit interesting that in both cases, it wrote out CAB. That's just coincidence. We could run this a few times and maybe we get ACB, BAC, BCA. The order, remember, does not matter for a set. Now, you might be asking, well, how could I actually create a string? Because I want to have a string as a set value. Well, if I'm just going about the process of creating it, there is an easy way. And it's simply, I can put my string inside of a list. So notice that now I'm passing a list to my set. My list item happens to have a string in it. So if I run this, you'll notice that now AAA, BBB, CCC is one big string. It's unique. The fact that it has repeating values and it doesn't matter because strings can have whatever they want. But it will be the only string that has AAA, BBB, CCC. So let's take a look at a little bit more complicated example. I'm going to create a list. And I'm just going to put 1, 2, and 3. And now instead of putting in a value, we're going to pass into set a variable. Which variable? Well, my list. So now if I run this, you'll notice that it has 3, 2, 1. Okay? When it prints out each individual one. The whole string is there. This is how we can add strings or group of strings very easily to our sets. It's nice the fact that we can, of course, pass in variables as well as a literal value because the variables give us a lot more flexibility. I could get this from some other place. Now, of course, the other option I could have done is I could have said my set dot, and notice I have an add. So here I can put in 4. You might go, okay, well, is this going to split up my word or is it going to add the whole word 4? I have 1, 2, and 3. Well, since we're going to print this out, let's run it. And you'll notice that when I use add, it adds the whole string. It does not split up that text. So another way I could have done this is create an empty set and then use that add method. That add method is just a way that we can add elements to our set. So we've seen this with all of our other sequences. This is how it works for the set. I can also, as with other examples, I can remove an element. So I can say mySet.remove, and now I have to give an element that it's going to be removed. So let's say 1. If I run this, you notice that it's 4, 2, 3. 4 was added, 1 was removed. Now you might ask, well, what happens if I try to remove something that isn't inside my set? So let me remove 5. If I go to run this, you're going to notice I'm going to get that key error. If you remember correctly from when we worked with dictionaries, key errors is anytime I can't find that key or the value that I'm looking for. So we always want to check to make sure, does this element exist inside my set before I go start removing it, or wrap it inside of a try except and catch that key error so that we can display something useful to the user if it's appropriate. Now, in some cases, it's more appropriate to just kind of ignore the error and keep on doing our program. Whatever's appropriate is what you want to do. Now, there is another option that we can do instead of using remove, and that is I can use discard. So here I'm going to discard 5. Let's do a CLS just to clear out my terminal screen, make it a little bit easier to see the results. I'm going to run this. Notice that it prints out 2, 3, 4, 1. When we went to discard 5, notice that there is no error. So this changes what happens. So which should I use? Well, it depends upon what am I trying to do. If I want to ignore it, I could write a try except and use the remove method and then have basically nothing inside of my except block. But a better option would be to use discard. So picking which method to use should all depend upon what is it that I'm trying to do as a developer. All right, so one of the things that we often have to do is we need to be able to loop through our sequence. Can we do this? Of course. So I'm going to say for, and I'm going to do ELEM, short for element, in my set. So this way I'm looking at each individual element. I'm going to print element, and if I run this, you notice it's going to print my values. 3, 1, 2. Remember, once again, they're still not the same order that I created them. It's just the order it puts them in. How Python chooses that order is kind of a mystery to the average developer, so we're not going to worry about that. Okay, but if I need to go through each individual element, I can. If, on the other hand, I need to see does an element exist inside of a Python set, well, I can use that in operator like I did before. I can say if to in my set, I'm going to do a clear screen on my terminal just to make it easier to read. And if I go run, you notice that 2, the item was found. If I say tree, okay, now maybe I meant to write 3, maybe I meant to write tree, doesn't matter. What's here is tree. I'm going to run it. Notice we couldn't find it. So it's looking for exact matches. You can't be close. It's looking for something exact. If I have 3, you'll notice that we found the item. But if I have 3 with a capital T, notice that it says we couldn't find the item. So it's all very dependent upon exactly what can or cannot be found. This is a perfect example of that. Now, when we use sets in math, a set by itself doesn't tend to be really beneficial. We tend to want to use it with other things. So we need to compare sets to other sets, and we need to find like what happens if we join these two sets together. Or we want to see what happens when we overlay the two sets and see where they have some commonality. So for example, I might be looking for people who are registered voters and people who live in town X. I want to see, okay, who's the registered voters in town X? That's the type of thing we're going to do when we work with sets. We're going to find, who belongs to a member of these 2, 3, 4 sets, and that way we can start to refine how much we're working. This becomes a little bit more of when we're going to be working in other areas outside of math as we refine things down. For example, in marketing, advertising, those types of things. So here I have 2 sets. Notice that these 2 sets have 0 overlap. Okay, it's 1 through 4 and 6 through 8. If I want to join 2 sets together, I can use the union command. But it's important to note that the union command, and a lot of these commands we're going to look at, generates a new set. It does not modify the existing set. So I have to say set3 equals set1 dot union set2. And if I print set3 and now I run this, you're going to see it creates the union or the joining of these 2 sets. Now remember, if it has a duplicate value, it's going to be ignored. So if I come in here and I say 3, 4, and then have the rest of my values, so now we're going to have some duplicate values in here. If I run this again, you're going to notice that it produces the exact same set. Okay, so it removes the duplicates. If I want to find where there are duplicates between the 2 sets and ignore where I only have data on one side or the other, I would use Intersect. So here's my intersection. And notice that they only share 2 values between the sets. Those 2 values is what is created input in my new set. So intersect, or intersection, which is the method that Python gives us, creates a simple way to find out what values are shared between 2 sets. Now, if I had 3 or 4 sets, how would this work? Well, I would have to find the intersection of these 2 sets and the intersection of those 2 sets and maybe take the intersection of the intersection. It's a few more lines of code, but in a function or in a loop, this becomes relatively easy if you think about it. Now, both the union and the intersection in Python have not only these methods that you can use, they also have some special symbols that you can use. For example, the pipe or the vertical line can be used to represent the union. So you can say set1 pipe set2, and it creates the union of two sets. Intersection has a similar type of symbol. However, I want you to remember that one of the things about being a good programmer is writing code that other programmers can read. And unless you use those types of symbols all the time, because you are a practical mathematician who's looking at applicable ways to use set theory, except for something like that, would a regular programmer instantaneously know what those symbols mean? Well, the answer is probably not. And so I recommend, and this is my, like I said, my personal recommendation, I recommend that you use union or intersection because it's a lot more instantly recognizable to other programmers. They know exactly what you mean. And therefore, it's cleaner code that other programmers can understand. So just kind of keep that in mind as you're working through some of your code. I might say, for example, dot difference set2. Okay, well, what is difference going to give us? Well, let me do a CLS real quick. And for those of you who are not familiar with set theory and set of math, we can take a look at this. And I say, okay, if set 1 is 1, 2, 3, 4, set 2 is 3, 4, 6, 7, 8. And when I do the difference, you'll notice it gives me 1 and 2. So what it's doing is it's saying, show me the elements in set 1 that are not in set 2. Okay, so this is showing a difference between the two, and it's only looking for the ones that are in set 1. We're not looking at things in set 2, we're only looking at things in set 1. Now, there's a similar function called symmetric difference. You might go, well, wait a second, what's the difference between difference and symmetric difference? Well, if I run this, you're going to notice that I have 1, 2, 6, 7, 8. So if you want to know what was different between the two sets, so basically what elements did they not share, the opposite of my intersection, now I'm seeing the unique values in both sets. Okay, so I'm seeing 1 and 2, because from set 1, those were not in set 2. And I see 6, 7, 8, because those were in set 2 and not in set 1. So there is a huge difference between symmetric difference and difference. Difference looks at what's unique to that specific set. Symmetric difference looks at what's unique between both sets. So I'm going to modify my set 2 just real quick. So now all my elements that are in set 1 are in set 2, but not all of my elements in set 2 are in set 1. This means, mathematically speaking, that set 1 is a subset of set 2. That means that all the elements in set 1 can be found in set 2. It also means that set 2 is considered to be a superset. I have all the elements in set 1 plus a few extra. Okay? Now, I can test for this inside of Python, and Python will return a true-false value. Let me show you real quick how we're going to do that. I'm going to say print set1 dot is subset. And then what am I a subset of? Set 2. This is only going to return a true or false value. So if I go and I run this, you notice that it returns true. But if I try to say, hey, is set 2 a subset of set 1, and I run it, notice it returns false. Okay? It's because set 1, all of its elements are found in set 2, but not vice versa. Now, is set 2 a subset of set 2? Interesting question. Notice it returns true, because all the elements in set 2 can be found in set 2. Now, should I do this? Probably not, but it's just mathematically speaking how that works. Similarly, there is also a is superset. So just as a reminder, usually whenever you see is, it's going to return a true false value. So is set 2 a superset of set 1? Well, if I run this, you're going to see it's going to return true. That's because set 2 has every element of set 1. Okay, so you have subsets, you have supersets. These are some of the most common things that you're going to use when working with sets in Python. Are there some other values? Yes, of course there is, but these are your most common ones that you can be looking for.